So today we're looking at oxidation numbers. So in fact, the definition of oxidation number is that the oxidation number is an integer value assigned to an element to show the electrons how they've been shared or gained or lost. So that's the statement there. So the oxidation number is also called the oxidation state. It's a number of electrons lost, gained, or unequally shared by an atom. So the integer value which you assign to show the number of electrons lost, gained, or unequally shared by an atom in a compound is called the oxidation number. So oxidation numbers may be, they are integers. Remember integers when you started learning integers in grade 4. Integers were numbers which were negative, 0, or positive, because the integers are those numbers on your number line. So if the oxidation number is 0, it means the atom has the same number of electrons assigned to it as they are when it is neutral. So a neutral atom has oxidation number of 0. The beauty with this statement, guys, I want to say something again, is that oxidation number for us now is what you guys in grade 12 used to say valency. I'm sure you used to say valency, remember that? So it's an improved statement for valency. The word valency will still be there, especially valence electrons, because valence electrons simply means electrons of the outermost shell. I'm sure you remember that. So what we're trying to say now is that a neutral atom has the equal positive and negatives, meaning protons, electrons, balance. And in compounds, it's only electrons that participate. You remember electrons are shared, lost, those are the cases. So now, the statement which we have to say there now is that if something has a positive oxidation number, it means it has fewer electrons than it has when it is in neutral. Like if something loses electrons, it becomes positive. So the oxidation number, especially even for the group 1 elements, if you remember the group 1 elements, the alkaline metals and the alkaline earth, which is a group 2. In compounds, the oxidation number is simply the charge on top of that. So it's very easy. So if it is neutral, we said it's 0. Then a negative oxidation number meaning it has more what? Electrons than it has when it is neutral. Because remember that electrons are negative. So that is the case. So let's continue. So the case is that when you look at the same, for ionic compounds, the case of oxidation is very easy. Why? Because in ionic bonding, a metallic atom loses electrons to the non-metallic atom. So e.g., when you have sodium and chlorine, sodium loses 1 electron, chlorine gains 1. So the charges there is that in sodium chloride NaCl, the oxidation number for sodium, which is the sodium ion, is a charge which is +1, and for the chloride ion, it's a charge of -1. That's all. For magnesium, it becomes different. It's MgCl2. So we are already aware that chlorine gains 1 to be stable. So for you to have 2 chlorines there, it means magnesium lost 2 electrons. So to have 2 less electrons, meaning the Mg, the oxidation number is 2. because it has transferred 2 electrons. And since the chlorine has gained, there's a gain of an electron each, the oxidation number for chlorine is still 1 because there are 2 chlorines there. So meaning for common ions, the oxidation numbers are simply the charges on the ions. E.g., like if you see those, there's a table there. So once you just are given a charge, whatever the case, if there's ionic bonding and you have an ionic compound and you are certain that this is ionic compound, e.g., copper 2 chloride, which is CuCl2, then you will know that the oxidation number is this one, Cu2 plus. So for ionic compounds, the oxidation number is very easy because it's simply the charge on the ion. Are you getting? Are you getting, guys?
Yes, sir.
Okay. So now, where there's a bit of work and a lot of analysis is in covalent compounds, because oxidation numbers there are based on relative electronegativities. So in covalent compounds, remember, electrons are shared between nonmetals. But then now on the periodic table, I think I explained that electronegativity is the affinity for an atom, for an element to gain electrons. The affinity for an element or an atom of an element to gain electrons. That is the electronegativity. So on the periodic table, some elements, despite being nonmetals, some elements are more electronegative than other elements. So meaning, the only case is this one where you have a symmetric case. So all elements have different electronegativities. All elements have different electronegativities. So meaning, if you just have 2 different elements, then the concept of oxidation number is different. One, they will have different oxidation numbers. One will have a positive, meaning if it has a positive electronegative, if it has positive, then it's a bit electropositive, and there is no equal sharing there. Even in the world, there is actually no equal sharing in the world. If you've noticed, you share with your friend, you umuletereko nani wabika professor ena esa no munani. That's not sharing. Is that sharing, guys? You aleta fesoti yeka ena aisa no munani. You also to state any kwacha ena umunani ashiro 50 wacha. But once you have shared one. So now the only equal sharing is when you have the same type of electrons, e.g. H2. So in this one, H2, Cl2. So this one, there is equal sharing. So the electrons are shared equally there. So in that case, the oxidation number is 0. The oxidation number is what, team? 0. But then, now in the case of unlike atoms, these are like atoms. So when you have like atoms bonded together, no matter how many they are, even if you have so many, guys, the oxidation number for them is always 0. Cl8 ngoko yaba. As long as it's chlorine bonded to itself 8 times, that is equal sharing. So that one, guys, will simply be 0. The oxidation number, because there's no separating to say this one is more electronegative than the other. But now, if you have different atoms, like the case APASO, where you have nitrogen and hydrogen, also you have water, ammonia and water. These are common compounds in the lab. Ammonia, guys, you can't stand it. It has the exact scent as very powerful urine, ammonia. So it's not something you can stand. Imoneka fe bwino mu buku ifine nga wasasangwa muri environment ya ammonia, you'll be choked. Those of you who are asthmatic, you can't work with ammonia. If you have breathing problems, if you're sensitive, so those are things. But it's very useful. It's a very useful compound. One of the places where ammonia is used is in cooling alcohol in a brewery. Why? Because the way its property ammonia, I can't explain its property, but if you put ammonia in a tube that has varying diameters, like apayashita expand, apayashita nani kashita contract ka tube, apay expand, reduce, expand. That expansion, gairesta undergo sudden expansion and compression. For each case, compression. For the tube, you say contraction. But if there's expansion and compression of ammonia concurrently, it becomes cold, very cold, like a fridge. So it ain't tubes are varying diameter. Protected, yes. Then nakameto akaba easy to send cooling, like a metal which is an easy heat transfer. Then alcohol in shidi cooled muna nidi chilled ichimena chile talala firafine ni shide talala mosi moisa mwanwa nense de mwatukana. So now these are the things. So in this case where you have ammonia and water, the electrons are not equally shared. The electrons are not equally shared. So in a bond, it's not always fair. A bond is like a marriage. It's like a marriage. Sometimes in some marriages you find umwali benefita muchupo, umbita benefita sana limbarana kumse. I'm sure you've seen those. It's like a marriage where you are together. Yes, it's a marriage, but I don't know chupo eche. But masangate umbi anasekera mwanene boss na wewe mami, that's my wife. Kusema kashona tababa mo. Even you guys, like you are dating, tabako pick up a DP na one day tabako pick up a DP, but you are the movie can be mukuten. Is that fair sharing, guys? So let's continue. Is that fair sharing?
No.
No, it's not. Eh?
But I'm behind.
Okay. So we're talking about so when guys, for this, what it means that one of them, like in this case, the hydrogen, seems to be the one that becomes, it's more electropositive in this case. So if you can use the periodic table to know which one is electropositive and which one is electronegative, you would know. So the hydrogen is more electropositive. So this electron has a more affinity to belong to the oxygen than the hydrogen itself. So meaning the hydrogen in both cases is more electropositive. So meaning the other one is more electronegative. So those are the cases. So to figure out whether this +1 or -3, those ones have been assigned in a table. So the definition for oxidation number is this one. I wish I made it bold so that you could have seen it. So the oxidation number of an element is an integer value assigned to each element in a compound or ion that allows us to keep track of the electrons associated with each atom. So then the last point, this point is statement, it's very key. Why? Because we are saying that these oxidation numbers, oxidation number, then the question is, like Abena Megan Marie, why you do some oxidation number? You can do. Eh? Nabena Edward. But you don't do Mr. Banda Edward Jr., if not the third. So now, these ones, guys, oxidation numbers have uses, very powerful uses. I said oxidation numbers for ionic compounds especially, we qualify them as the valency, which is the combining power of the atom. So now, for chemistry, the oxidation numbers are used in the following writing formula. Predicting properties of compounds. So looking at the nature of the oxidation numbers, you can know what a powerful oxidant or what a powerful oxidizing element is, or what compound that you have is, what properties do you expect. Then lastly, so you can predict properties, write formulas. Then lastly, which is also most important, is that you use the oxidation number to balance redox reactions. Because there are those equations where there is oxidation. Because oxidation is what ni pregnancy. When there's oxidation, when an element is oxidized, each one has been reduced. Takwa bati tikefe yeka oxidation. Shimona pregnancy. Like you gakudu podire fumo, ni shipadiyo pelele mu community. My mother, by oxidation, it's like that. When there's someone who's gain, some electrons. So even the elements it's like that. So if one has gained electrons, then one has lost electrons. So it's always like that for oxidation. Oxidation. Then that one, when you are just showing oxidation alone, that equation is called a half reaction. Why is it a half reaction? Because it shows electrons, it shows electrons just there in the equation. You are showing electrons. So now, to finish the reaction, you should write another half reaction that cancels out those electrons, because you cannot be seeing electrons in a reaction. All you see are the atoms. This one loses electrons, then the electrons are accepted by the other one. So if one atom loses electrons, the other one accepts. So that's how it is. Our lecturer used to say oxidation is like begging and giving. The beggar receives money and becomes poorer. The giver gives money and becomes rich and becomes blessed. So even oxidation is like that. The one that gains electrons becomes reduced. The one that loses electrons becomes oxidized. So now, the starting point is that elements that are in their free state, whether they are monoatomic, diatomic, polyatomic, as long as it's in its free state, the oxidation number is always 0. So those are the things. So the rules, that's why I told you that I won't base on the atom and say no, because hydrogen there was coming with one electron only, so it was losing one, like was small electropositive, so it was given to the what. So since small electropositive and loses one becomes H plus, and then that's plus one, then that one gains 2 and the other one gains 3, so it's -2 and -3. That reasoning is not very helpful for you to analyze like that, and it's very unfair. So what will guide you are the rules. Number 1, elements in their free state and combined with other elements have oxidation numbers of 0. That's have oxidation numbers of 0. NaCu, Mg, H2, O2, CO2, N2, O3, S8, even S4. Anything as long as the element if bonded could yeka, the oxidation number is 0. Then hydrogen has oxidation number +1, except in metal hydrides where it's -1. So the metal hydrides are those NaH, CaH2. Those are metal hydrides. Hydrogen is -2. So oxidation number you can also liken it to love. You can't say you have love when all you have loved is yourself and your relatives. So to have more love is to love strangers and the neighbors. Umuchushi wamupera insapato walikwata ishiri 20 vana mai kula vatari kwata insapato ishiri 40 shimbitafwara pono kufwara bakose vari vanichikulure chula. So it's like love. You can't have love and say you have love if you have not given it away. It's biblical. It's biblical na save one another. So number 3, oxygen -2. So everywhere where you see oxygen number is -2, except in peroxides where it is -1. And there's only one element, this one, OF2. Why? Because fluorine, as I told you, is the most electronegative element on the periodic table. And the fact that it's the most electronegative
I have a question, sir.
Yes? Innocent?
I have a question.
You have a
Yeah,
question?
you
Innocent,
said hydrogen.
Innocent, usangwa class ya vidis. Choose one. In fact, nalikuwa kalua mo extension yo. So ne chungulo 16 hours uleba mu class foot.
So I should join the one for 16?
Yes, but you can
All
ask
right,
the
sir.
question.
I'll do so.
This is the last one you have.
Yeah, a question. You said hydrogen. You said hydrogen element, it has a positive oxidation number when it bonds the hydrides metals.
Except
why is it that it has a positive number since hydrogen is not a metal, it's a non-metal?
Yes. So I've said when it bonds with metals, it's -1. Like NaH, it's -1. CaH, that's -1. But when it's just bonded with other elements, then it will be +1. So meaning, in short, we're saying rarely does hydrogen bond with metals. If it bonds with metals, it's -1.
So does it
what?
So does it imply to say it possesses both the characteristics of metals and non-metals?
No, it just means hydrogen is more electropositive. It is more electropositive than all the non-metals. So it's one of the most electropositive metals. That's what it means.
All right, sir.
So then for ionic compounds, the oxidation number is the charge on the ion. So metallic elements in ionic compounds should always have positive oxidation numbers. The charge on the ions, there's a table there. Now we a table for ions. Ag+, it means oxidation number is +1. A Bl2 +2. Then, so the oxidation number for an ion is the charge on the ion. That's what it simply means. So the negative oxidation number is assigned to the most electronegative atom in a compound. That's how it is. Then this last statement is very important, these last two. That for a compound, the sum of the oxidation numbers is 0. While for a polyatomic ion, the sum of the oxidation numbers is the charge on the ion. E.g. now 30, NO3 minus. Now we monitored. It means when you add the oxidation numbers here, then the answer should be -1. So now, these are the ones you know. Rules, they'll guide you for the ones you know. And then you will use these very rules to find the ones you do not know. So the rules are that the first rule, you write the oxidation numbers of the known atom below the atom in the formula. For example, CO2, it quite a example A. So under oxygen, we write -2. That's the way it is. Then multiply the number by the number of atoms of that element in the molecule or of that compound. So since there's a 2 upper punch, we'll multiply this by 2. and have negative 4. Then we'll write an expression, because in short we are finding the oxidation number of carbon here. Because here oxygen not wish wapo ilikali pama rules. Tapata banga kuipisha to find the oxidation number of oxygen here. The statement should be state the oxidation number of oxygen, because you should have known it from the rules. So then you know by equation, because you're looking for carbon, so you write carbon plus minus 4, because minus 2 times 2 is negative 4 equals 0. So C minus 4 is equal to 0. When the negative 4 crosses the equal sign, it becomes plus. If you've seen Palmer oxidation numbers, we always emphasize ukulemba charge. So that is all. The examples are self-explanatory. Here hydrogen natuimonani plus 1 to abika plus 1. Here oxygen negative 2 to abika negative 2. Since there are 2 hydrogens, we multiply times 2 to water plus 2. Then since there are 4 oxygens, we put times 4 to water negative 8. Or to remember expression, plus 2 plus S minus 8 is equal to 0. And then we change the subject to the formula to S. We'll find plus 6. Here, polyatomic ion A twachilala ndandaka E. Apa pali MnO4 minus. So the oxidation number of everything in our Panga expression should be equal to the charge, which is negative 1. So the 4 times negative 2 will give you negative 8. When you work this thing out, you get plus 7. So all that I'm expecting from you guys is to know how to express these things, to practice them more, because they are useful. So some people even attempted this work, and I even responded. This is impressive, guys. I stand to be corrected. I stand to be corrected. Okay, I'll check. So guys, go and practice this, unless there's someone to emphasize a point before we summarize, because we have 5 minutes. Any question, any guidance? For the oxidation number, I'm free. I'm free.
Yes, sir. Due to connection, yes, Mr. Danulo, sir.
Yes.
Due to connection problems, I was disconnected. So I'm kind of asking if you can repeat on these examples, just starting from one. I think that is enough.
No, the rules are here. I was just emphasizing these rules when solving. You write the oxidation number of the known atom below the atom in the formula. So meaning, if you have CO2, the one you know from the rules is oxygen. You said it is negative 2, so you put it down there, negative 2. Since there are 2 of them, that's the second rule. Multiply the oxidation number by the number of the atoms of that element in the compound. So since there are 2 of them, or in the molecule of the compound, that's what you should say. Then you say 2 times negative 2, which is negative 4. That's all. Then you write E, this is carbon, the one we're looking for. So you say carbon plus negative 4 equals 0. Remember, plus minus is minus. So it's the same as saying carbon minus 4 equals 0. And then this 4 crosses there, it becomes plus 4. So the oxidation number of carbon in carbon dioxide is plus 4. Then for this one, the oxidation number should always be equal to the charge on the ion. So we'll put a negative 2 there, because for oxygen it's always negative 2. And then since there are 4 of them, we multiply times 4, we get negative 8. So Mn minus 8 equals the charge, which is negative 8. For a compound, we said it's equal to 0. But for a polyatomic ion, it's equal to the charge on the ion. That's how it is. The last one is more interesting, because in the end, you even get to divide. Why? Because you have 2 of the carbons. So you say 2 times carbon minus 8, which is 4 times negative 2, is equal to negative 2. Then 2 times carbon, when this negative 8 crosses the equal sign, becomes plus. Then minus 2 plus 8 is plus 6 over 2, you get plus 3. Otherwise, fair in a cave. Bad. So now, the idea, guys, is to know these ones, especially the one where I said oxygen here is negative, is positive 2,
Yes,
OF2. So ngamwai mone OF2. Taisangwa sangwa so ngasa isa muri question wasamba what is the oxidation number of oxygen in OF2. Ufile waishi bata iya masetin madenje ile ba positive 2.
yes, sir.
Not about programmed at no Jones oxygen ni negative 2. Yes?
On carbon dioxide, I'm not clear.
What do you mean you are not clear?
Because
What? The oxidation number for a compound is 0. Then oxygen from the rules is negative 2. And then there are 2 of them. 2 times, there are 2 of them. That's why you multiply by 2 here. It's negative 4. Then when you add this, they should give you 0. Then you change the subject to formula 2C.
okay, yes, yeah, there it is clear now. Where I'm not clear, it's carbon. Carbon, is it a metal or a non-metal?
Boy, oxidation number ushenaenda napo fyama metals if you remember that.
No, sir, because looking at
oxidation numbers, sir, it's electronegativities. The one which is less electronegative, which is electropositive. So even in covalent compounds, if you have carbon and oxygen, one of them is more electronegative than the other. That's the establishment. To find the positive oxidation number for carbon, for instance, is not an indication that carbon has become a metal. No. It just means carbon is more electropositive. So to ask a question to say, Bushea look a metal, takwa bayo.
okay.
In all, as long as you have different elements, the oxidation numbers are different. Different how? One will be assigned negative when it's more electronegative, and one will be assigned positive, meaning it's more electropositive. Moffat, I'm sorry, there is no time. You can ask on the study master. So guys, just go and go through these rules. Yeah, question Davis is very good because I mean, you must have a conclude only metals should have positive. Now, for a lot of you, that's why now punch and punch.